Good day, everyone. I'm Kathleen Faye Amayamas from BT Garments 1B. So, let's discuss about patterns and number in nature in the world.
Pattern indicate a sense of structure in organization that it seems and only humans are capable of producing this intricate, creative, and amazing formation. The first pattern we'll discuss about symmetry. Symmetry indicates that you can draw an imaginary line across an object, and the resulting part are mirror image of each other. One of the examples of this nature is the butterfly. The butterfly is symmetric about the axis indicated by the line. Note that the left and right portion are exactly the same. This type of symmetry is called bilateral symmetry. Leonardo da Vinci's Vitruvian Man showed the proportion and symmetry of the human body. Example, when you look at yourself in front of the mirror, what you see on the left side, you also see on the right side. Starfish. There are other types of symmetry depending on the numbers of sides and face that are symmetrical. Example, if you rotate the starfish, you can still achieve the same appearance as the original position because the starfish have a five-fold symmetry. So we call rotational symmetry. Another example, the tiger stripe and hyena's spot. Pattern exhibit in the external appearance of animals. The tiger looks and hyena spot. These seemingly random design are believed to be govern the mathematical equation. And according to the theory of Alan Turing, the chemical factors in the cell determine growth pattern and influence factor like hair color. There are two chemical processes, reaction and diffusion. The most recent study, the one who said some space group vertical stripe is like this, with tiger stripe, a new model by Harvard University researchers predict that there are three variables that could affect the orientation of this stripe. First, the substance that amplifies density of stripe pattern. Second, the substance that changes one of the parameters involved in stripe formation. The last one, the physical change and direction of the origin of this stripe. Another example, the sunflower. Looking at sunflower, this is a defined patterns of clockwise and counterclockwise are spiral extending outward from the center of the flower. The arrangement allowed the sunflower seed to occupy the flower reed in the way that maximizes their access to light and necessary nutrients. Flower petals. Number 1. Flowers are easily considered as things of beauty. 2. Flower 5 petals are said to be the most common. 3. Numbers of petals are Fibonacci number. Another one is the snail shell. The snail shell. As the snail shell grows, their shell also expand proportionally. This process result is refined spiral. Example, when the snail shell grows, its body also grows. Also, the population growth. Mathematics used to model population growth with the line formula. A is equal to P times E raised to RT. A is the size of the population. P is the essential number of people. R is the rate of growth. T is time. E is the Euler constant with an approximately value of 2.178. Example, the exponential growth model. A is equal to 30 times E raised to 0.02T. Describe the population of a city in the Philippines in 1000. T is years after 1995. That means starting is 1995. So let's try to answer. What was the population of the city in 1995? First, let's take the population in 1995. Given the in potential growth since the starting years 1995, so the value of t is 0. They're our given. We just substitute the value of our t and that is 0. So we substitute here is 0.02 times 0. Any number is 0, so any numbers raised to 0. The answer is 1. 1 times 30 equals 30, and this is 1000, so means the population city in 1995 was 30,000.